Нормально.
Ломите все у 16.
256.
Идите вы.
It cost without any discounts 900 rubles.
У меня SSD, надо мне выкинуть 56.
У меня 500, но как бы
No.
это ноут.
Yes, plus 1 terabyte. If I have any problem, I can just plug it in. Okay, so today, actually, Molotov told me about midterm, no?
No.
Okay, midterm will be after the statics. So first, midterm will cover statics and blah blah. Kinematics, yes. So for today, we will cover the spherical motion because you told that you have some problem with it. We will solve the task which I gave you to do it at home, and after this, we will start to prepare to exam. But as usual, we are starting from no questions for this time. Thanks to Nabil and Seb that you visited as a class. So,
So like next time will be approximately next week or the week after?
It seems not next week, but next week.
Спасибо.
Framing this case is a planar.
Coordinates. Okay. It's from Stanford course. Introduction to Robotics. free, .NET will complete, and I put the minutes left. Time's up. Don't forget to highlight this. And your name. Don't forget to write. Okay. What was the first? Actually, what was the first type of angles and what was the second? How many type of angles do you know?
It means like
The angle, shape angles, or fixed angles actually, and pattern nuance. So what was the first and what was the second?
Так, first is alien.
Yes, the second.
Is alien too?
Shift. You should write one equation. In this case, it just prove how to shoot to take it. And actually the answer is following. Yeah, words sometimes.
probably to the right side.
Should be a stylus.
Yes. They won't find it.
The fifth.
Okay, how it works if I didn't connect? Ah, it's connected to the laptop. Okay. So let's So let's write the answer, and after this, let's understand how we went.
Почему здесь первая фраза? Понял.
Who opened the video which I added? It was exactly the same. So
Which
the very last slide. So so what's the difference between Euler angles and the shift angles, so fixed angles? Actually, in other words, called fixed angles. Who can explain?
Basically, the range, like, we represent each axis, so all of them do the rotations, but depends on, like, which one do you take as, like,
This is the shift angles and relative, and fixed are absolute. Actually, the Euler angles, when we're talking about them, for instance, we need to rotate. Let's read. We have a frame B and frame A, blah blah blah. Frame B is rotated about y-axis by angle, and after this angle. So, and we want to go from A to B. So it means that, firstly, we just need to do what was said there. We have frame B, and originally we need to rotate around y, so x, y, z. So around y-axis on angle theta. Boom, we did it. So after this, we need to rotate around about new z-axis because it is new z. It was old, it's new, and we rotate around this, and we just rotate it because it's transformation. So originally, we have one stuff, and we just do this in this manner. That's it. So after how to write 3 over 3 matrix, I hope it's obvious in this case. We just need to remember that how to derive y and z. I mean, where is cosine and sine. Actually, you can find this using projection if you don't remember the exact solutions. I mean, you just draw it, and when you rotate, you can just, so for instance, we have initial, and after this, let's say new one. And we know that x, y, x new, y new. Yes, this you just project. This is, I want to find, so it's y on x-axis, y star on x-axis, this point. And you just project it. Boom, boom. And after this we can find the solution. In our case it's 3D, but I wrote it for the video. The last one looks more complicated, but actually we did the same, but in opposite order. So we already have this position vector which we found in first task, and so in fixed angles. Actually, I need second hand help. Could you make a okay. So in the first one we use a new, let's say, when we make a new step, we used a new axis frame. In this case, if we need to rotate around some axis, we rotate it, but we still rotating around the original axis. According to the equation, actually it can be proved, and it was proven on let's say lecture from Stanford University. It will be let's say you just need to change the opposite direction. So if we're talking about zyx for other angles, it will be if we are using the same angles, it will be equal to xyz for fixed. I already put Hangouts and this, and you can read it if you didn't. Actually, and you just rotate around the axis firstly, after this y-axis, but we had to put it in before because we are rotating around, let's say, the original one, not a new one. And we just put it together and solve it.
I have one question that was confusing for me in the lecture. It's like when we are trying to go back from the new position to the old position, should we use negatives of the angles or no?
Ah, I see. So actually, when we are talking about transformations, yes, homogeneous on X, where it should be a new one and where is old one? Where is our, this is old points or this one old points?
The old points is the result, right?
Right, no,
The old points is the result.
it's a new point, this old one. Yes,
On the H.
because see, I will explain on the manipulator. H is homogeneous transformation, which was explained on first lab.
You mean like the 4x4 matrix?
Yes, it's called homogeneous because it consists of translational and rotational simultaneously. When I talk about manipulator, for instance, let's assume it's all we have L1, L2, L3, and we have angle 1, angle 2, angle 3. I explained that I can choose other way to choose the angle, but it's my decision to use the previous state as a new angle. So what I'm interested in, I want to know this point respect to bases, because we usually know where is robot positioned. For instance, we can install it or something like this. Or we can use computer vision to solve this problem. I did it on 2 hackathons. How it look like? You put camera and you put QR code near to the base, and you know the static transformation from the base to the from the table to the base of the robot. And using camera, you can understand where it's position the object itself. And using this kind of transformations, you can find needed solution. So let's return to this. What I'm doing, I want to find this point. I'm going from one to another, from one to another. Actually, we can do the same in our tasks, but usually we have closed loop system. It's the reason why using geometrical way. If you have open loop system like this, there is no any ground and so on. It's easier to use just transformations. So I'm starting from this. Where is how can I find this point? Yes, it will be just rotation around z. That's it, and multiply on on length. Actually, if we are using homogeneous form, it will be like this. In this case, we can just multiply. After this, we multiply, so we are there. But actually, we found this point in respect to this, from A to B. So, if you calculate it, in this case, we are assuming this as a new basis. It will be 0, 0. So in your case, it will be 0, 0. So when I ask you this one, it will be R, Z, L, 0, 1, 0, 0. And multiplying on this, we are finding this position respect to old one, not to the new one. So it will be, in our case, I don't know, if we are assuming that it just up, it will be, I don't know. It seems that you lost. Okay.
Multiply by 0.
Yeah,
and you get non-zero.
Okay.
Because you have one.
No number of columns is okay.
Because it's homogeneous, I mean, because it's homogeneous matrix and I have to put the one in the end of column. It's the reason why it have not negative, I mean, not zero value. So it's the reason why I put one there too.
Why L isn't in the first coordinate if it is in the first row of the matrix?
According to homogeneous consists of rotational matrix, 0 dimension of this matter. So we have 2 by 2, it means that we have 2, 2. There we have translational, in this case it will be 2 by 1. So, bam bam, and 1 there.
Where is L1? Okay.
L1, I just, in this case it will be, let's say, it depends how you, how say, according to x-axis. Actually, how can you think? It will be L1 there, 0. How can you think? Okay. I'm preparing to explain the two linear algebra students actually. So we have one axis. We want to go this. Does it matter what we are doing first, rotational or translational?
Yes.
What we are doing first?
Rotation.
Translation.
Actually, let's try. You have how to say, sell the nodes. Тетрадь. Draw. Yes, you can find the solution by yourself. I mean, take for instance 90 degrees. So draw it using the cells in the node. And for instance, one solution and other solution. So I just rotate it on 90 degrees. And do it in one case and do it in another case.
Just for rotation and translation. Rotation and rotation.
No, there we rotating our, how to say, we rotated our coordinate system. After this, I'm moving along x-axis. It's the reason I'm writing like this.
I mean, you can do it the opposite way and it will arrive to the same point with the same
Try.
orientation.
Try.
No, it's gonna be a different.
You have a cell node. Try to do it. If you don't have, I can give you.
No, I mean, so when we translate in accordance to the original system, to the absolute system, right?
No, the current.
To the current, okay, so then it's, of course
Right.
it will be different.
So you need to understand what we need to do first.
Yeah.
Translation and rotation.
I was talking about
Rotation.
my question, like at the very beginning, when we do a rotation and we want to undo this rotation, should we take the negative angle? That
Not
was-
negative, no. Actually, you cannot do like this. You have to do inverse.
The inverse of the matrix.
Yes. Actually, the translation.
Question.
Yes, but... Степан, ты не помнишь, что делать?
Понял.
Ну так делай. Рисуй. Вот, нарисовал один,
Я
второй.
уже понял,
А теперь
что
считай,
рисуешь.
и что первое надо делать. Когда?
Поворачивай.
Ну, это.
Можно так и сделать.
Давай,
Нет,
пробуй.
нет, нельзя. Только поворачивать, а
Почему?
потом трансляция.
Вот проверь.
Смотри,
Так легче, но можно
вот у
так
тебя
иначе.
ручка, да, вот она под таким углом, да?
Я могу
Вот у тебя вот так вот,
сместить,
ось
а
координат,
сделать
да?
поворот. Допустим.
Тебе надо повернуть ее, да?
Да.
Смотри, если ты сначала повернул, и потом передвинулся, у тебя там дальше что-то происходит, тебе не важно,
Легче.
то тебе нормально, у тебя вот, по точке она перешло просто по прямой. Если ты сначала перешел, тебе потом вот это вот все надо вращать говно.
Нормально. Нет,
Нахуй
здесь
тебе надо? Поэтому ты сначала вращаешь, потом двигаешь.
Ты можешь изначально сделать вот так, а потом сделать вращение.
У тебя...
А ты
двигаешь относительно начальной точки.
Ну вот сначала.
Ну,
вот
ты
так
сначала
вот
повернул.
двигаешь, а потом делаешь.
Хера, отличное действие.
Так можно.
Так можно?
Это глупо, но можно.
Так, у тебя получатся разные числа, если ты будешь строить одинаковые повороты. Мы когда говорим про повороты движения, смотри, я
Ну, я
говорю,
ж
что
про-
я должен перевернуться на L.
Олег, я ж
Да вот проверь, нарисуй, проверь. Практика мерила истины. Зачем мне что-то
я вот
обсуждать?
показал.
Ну так ты сделай и докажи
Да,
на
ёп.
бумажке. Я вот на
Доказать
номинале тоже
так я
заставляю
тупой.
студентов таким образом. Потому что ты не поверишь. Знаешь, как бы зачем верить мне? Я могу ошибаться, если ты можешь взять и проверить руками.
Ну, я вот.
Нарисовав клеточки. Используя клеточки, просто посчитать.
Выполняется бесконечное точек. Просто всех есть точка либо законоплоскости,
Что за так? Ну все, посчитал, что мы должны делать первым?
Наверное, поворот.
А может все-таки ты посчитаешь?
Я думаю, посчитать.
Ты имеешь следующее. У тебя известный перенос. От 0 до 0,1 сколько будет? 3, 4, 5, 6. Раз, два, три. Нет. Зачем тебе 12? Тебе координаты нужны. 6, 3. Translation. 6, 3. Здесь поворот на 90 градусов, правильно? Правильно. Соответственно, какая будет матрица поворота на 90 градусов? Косинус 90 минус синус 90, синус 90, косинус 90.
Как он там расходит?
А теперь ты вначале сделаешь поворот, а потом передвижение. А вначале сделаешь движение, потом поворот.
То есть еще раз, у нас когда есть формула x равно матрица, какой-то оператор смещения умножить на другие координаты, у нас справа координат новый.
Справа координаты новые.
О, выросла полезный слайд.
This was exactly my question. So we have the vector v and o, like the new one.
Yes, it's new.
Yeah. So this new one, when we try to return to the old one, so it will be negative for thetas. Because these thetas were calculated when we
Даже тут мы сначала двигаем, потом
So, the, again,
I don't care about the translation. Only because
А, да.
so
Здесь
translation
ничего
I
нет,
understand
потому
the
что.
calculation, like
Лог.
even for our task,
Ну все.
the task that we had in the base now.
so you rotate in one way, you want to return.
Yeah, I rotated the frame. I rotated the new frame, like for example frame B. I rotated it on an axis with angle theta, and then on angle phi.
If you do about one angle, yes, you can just make it negative.
So yeah, theta and phi, and then when I want to return a vector from the new B to the old A, I need to take minus phi and minus theta, right?
No, you can, if you want to go to, you move from one direction, if you want to inverse matrix.
No, but in our case, the solution in our case, we don't inverse the matrix because we are working with Euler angles, and with Euler angles, we take it like in the reverse order already, like by definition.
Они просто находят
So we take the,
координаты
like we moved
точки
in
старой координат системы.
like y then z, but we wrote the matrix
Новые,
as
Они
z.
в новой или?
Нет, смотри, у них а это вообще vx, vy равно поворот и координаты системы. То есть у них новая система это данные, поэтому они сначала они делают пространство, перемещают, потом поворачивают.
Ну, один фиг сначала двигают, потом вращают.
no, I want to find the old. I have the new from the frame B, and I want to return it to the frame A. So, but the rotation matrix was calculated when
So
I
in this
rotated
case-
this original frame.
So we have, okay,
It's exactly the task that we have, like task number 2.
Чего страшного? 6, 3, там еще.
This is only
I
translation.
made
Это
it,
если
but
ты
actually it's not, it doesn't
сначала
matter in our case.
What?
вращаешь
Doesn't matter.
пока.
The translation?
Так.
Because if we are using homogeneous
Нет.
transformation, in this case we can just put everything in one equation.
So, does it have rotation?
Если прибавить.
Минус 1.
Okay.
Подожди, это начальник координаты, да?
This is not
Нет,
use
это
x,
смещение.
let's use
На
h.
сколько сместить? На 4? Да. Это вращение, да.
So we want to find a
Начальник координаты.
because
In, I want to find A in x1. In
a
the
in x y, and you are doing this exactly this equation doing the same this one.
yeah, I just want.
No, yes, and you want to find a star a dot if you know x. What do you want to find? So
So I have the result, I have the rotation matrix, and I want to find A.
so in this
that's
case
what.
you're doing yes.
Okay. And if I want to find A star, I have to get the inverse, not take the angles by negative. Like I
Yes,
know that
because of
the-
yes, because of equations.
yeah, I know because of equation, but if I have a different R that was calculated like in the opposite way, then I take it.
Actually, just do f. Actually, it's not inverse will be there. It will be transverse, transpose. Because definition in rotational matrix, inverse rotational mass is equal to rotational transfer.
The opposite rotation. When we take the transpose,
Yes.
when we take the transpose, that means the opposite rotation.
Yes.
Ah, okay, that's what I want to show. So if we have this matrix,
So
like
it will be like
cosine
this.
sine,
R or R transpose.
so if we have cosine sine, it will be it will
Minus
be
sine,
cosine-
sine.
Yeah, they will switch.
So what we are doing first, rotational translation.
Rotation.
Translation.
Rotation.
Процесс
Если
translation.
translation, тогда у тебя будет как по-другому.
Ты пишешь, что translation followed by rotation is different than rotation followed by translation. Считать, master. Actually, why I think about homogeneous? Homogeneous helps you to avoid all these problems. Because when you have homogeneous, you don't need to think what we are doing first, rotational, translational. If you put it all together inside, it will work. Because of math. That's it. So,
And now I understood why is this one is there. It's the scale of the matrix.
yes.
I didn't know.
Actually, it's the reason why I told you that actually we are not using these guys, it's equal 0, 0, because it's about bending. So it's, how to say, usually variable is orthogonal spaces. But in this case we can do it not orthogonal. And one is about scale factor. But usually in robotics it's also useless. It's the reason why you just not to think, and you just put 0, 0, 1. That's it. Actually, if you don't understand some kind of matrices, you can just draw it in Matplotlib or whatever, and you can look how it works. Okay. Let's go to the bullshit test. Say what you didn't get.
Is there some rule that says that we cannot take L as the center of zero velocity in terms of C? Because I understand from the solution that for C we need to take n as the center of zero velocity.
Because actually you don't have the center of IC. Your RC is not a point; it's a line.
They mean like why do we take n instead of L?
What the because of angle you see, let's say it should be the shortest distance.
So shortest distance from.
When we're talking about I give you an example. When we're talking about even in, let's see. So we have equation omega square, cross product r. This r is the shortest distance to your point of rotation. It's not, in your case, the shortest one, it will be this perpendicular guy, not this one. It's only the reason.
It doesn't rotate in plane of C.
It rotates around its own. There is no slipping there.
No sleeping. Without friction.
Without friction.
But
Without
it's
friction means
a bit
like
different.
it's smooth. Like this was.
It's
also-
actually without friction, without sleeping, most of the time the same. You don't need to think about this. You just know that you have 1 degree of freedom. That's it. The main problem of all this task, as for me, it's who opened solutions. Okay, Zahar, Safe, Span. Is you did
What
it?
did you ask?
I didn't open solution immediately. What? What's the point of opening the solution immediately?
It was the task for you on next previous week to open it.
Also,
Maybe I skipped
another
it.
question is NC perpendicular to VC? Because this was also confusing for me. Like,
And see to
because if this is the instantaneous center of velocity, then VC should be perpendicular, or at least have a perpendicular component.
see,
to
I
it.
don't see it.
VC is the vector of velocity from point C. Point C? Yeah, VC.
Ah, yeah.
It's should not be equal actually.
It's to pass.
It should be perpendicular, right?
Like this.
No.
Why not?
Because, why not? Because it should be from instantaneous center of velocity, and it should be like,
It cannot go down. Tangent to NC, yeah.
for B, I understand that it should be curved, like it should have a down component.
The problem.
Should not have it down.
Actually, for our purpose, it doesn't matter the direction of the points C in this case. I mean the whole direction. Because you just need to know this perpendicular to n, and we can find angular velocity. I mean the big, the big omega. That's it. Okay, the main problem. So the main problem of this task is how to find the E. Because you don't know the direction. And what does it mean with A? Is the main technical problems in this task. Why it's happened? Because okay, I will I will write all equations. So omega is equal to VC divided by HP.
Why should it here be E if VC is constant?
Again?
If VC is constant and HZ is constant, then omega of C is constant, then why should it be here?
Should be what?
Почему тут ускорение должно быть угловое, если омега постоянно у C?
Что это, в принципе, за ускорение?
So why we even if the first link doesn't have any acceleration, it doesn't mean that others won't have. Actually, in some tasks you can find this problem, so we need to find. Actually, in this case, you have two velocities: one velocity and second velocity.
Second.
Or angular. You have rotation around the axis,
Yes.
and you have instantaneous rotation around the ground. And
Откуда и
what the definition of angular acceleration?
derivative of angular velocity?
Okay. What the do we again? What the problem? You're thinking in terms of scalar.
No, in terms of.
In terms of vector, we have the changes because our omega rotates and it makes a circle.
Yeah.
It means that we have angular acceleration.
But it has another direction.
Yes, direction means cosine, sine. In this case, we have different numbers.
So E is angular velocity of what?
E
Angular.
Yes.
is angular acceleration of your cone.
Yes, angular acceleration of what? Of cone?
Of cone.
Okay. And omega is angular velocity of cone.
Где?
So it's the main problem for you.
А точка М.
So yes, it sounds ridiculous for us that angular acceleration equal to linear velocity equal to this, but it works because of vectors. So what the how to say? This guy is the omega dt. Actually, I put it there. Also, what say linear velocity of Vz what will be?
Omega of A. Omega T.
Because the magnitude of this rotation is omega as a vector.
What is this magic?
Когда волосы нужно оторвать.
I do not think
Because when we are
it should be fine.
according to the definition of angular acceleration, it should be tangential to Gadograph of your
Easy.
movement. Actually, Gadograph you can think in terms of that curve that makes each time. So your angular velocity. Okay, let's think in terms of linear acceleration. We have some line, we have velocity in each time. And we know that tangential acceleration should be tangent to our curve. In angular velocities, we don't have, normal angular velocity and tangent angular velocity, acceleration. Because we have only one, how to say, component. But it also should be tangent to our movement. So in one case we have angular acceleration velocity, second angular acceleration, and in our case it makes a circle. It should be our angular acceleration should be tangent to this movement. E. And also in our case, linear acceleration of omega Will be, yes, we know the magnitude.
Radius.
Is the reason why I understood that actually for understanding this you have to do home task because you need to play with it, you need to get it. Is the reason why I gave you one task for you and one task as a home task. Because I understood that actually I cannot explain it that you understand it easily because you just need to play. It's very actually before this class I spent 1 hour to think how to explain this. Because for me it's not so trivial also. And for more complicated cases, I also fail. Because we used to think in planar case that our angular velocity is a scalar actually. Yes, we think about a pseudo vector, but we're not thinking actually is it a vector. We think as some number with some specific stuff. In this case, we need to think also as a vector. And we can summarize vectors, some vectors we can do something else and even more with acceleration we have this stuff.
I just have one question.
Yes.
Omega is flat on the ground, right?
Omega is a instantaneous vector of angular rotation around
Of the cone.
of the cone.
Cone, like rotation.
Do you remember when we have a wheel?
Mm-hmm. Yeah.
So in this point, it's our line OL.
Mm-hmm.
And what will be omega? Omega will be rotated regarding to this point.
Okay, so
This
this
is-
omega is the equivalent of the 2D case of this one.
Yes.
Okay.
Because we have this omega, but also our guy rotates around z. In this case, it's more flat, But we also have another, yes.
Okay, so since we are looking from the side, this is like how the vectors go. How do we know the magnitude? Is it given? That's
How we found this magnitude?
Yes.
The magnitude of omega.
We found it. Because we know the linear point of this point. It was given.
Okay, so
Yes.
this omega is the equivalent of the omega of the whole cone.
It's a component.
Omega is the linear, the angular acceleration, instantaneous angular acceleration of the cone. Right now it rotates like this.
Acceleration
No, velocity.
Velocity.
of the cone. Okay.
Nice. I agree.
I only have one question. How is it provable that VA, the linear acceleration of point A, which point A is defined as a end of omega, is the same as angular acceleration of omega?
Actually, about this, I just found it. See that ветер главу скорее равен скорости движения до конца новой скорости по годографу. Годограф, as I meant, it's just the curve. It's one.
I can get the direction, but
And also, in this case, скорость точки конца вектора мгновенная, because, let's say,
oh
it's also a vector. And we can find the point, vector will, let's say, because it's vector, we can find its point. Point doesn't have angular velocity, rotation, it have only linear part. And how to find this point? We can just take the vector.
It's just the same derivative.
So we can think in terms of, let's say, in first case, we are thinking in terms of, let me say, not scalar, I don't know how to say.
Just the definition of
Yes, definition of acceleration, it's, let's say, derivative. It's
derivative of angular velocity.
omega current minus omega current minus 1 divided by dt. So it's one case. But also it's a vector, and our vector have a point. And we can find a velocity of the point. What will be the velocity of the point if we know the position?
same thing.
The same thing. You didn't get, you just
God damn.
So take some weeds, spend some time, And yes, one of those you can ask me, we can try to do it again. Actually, I put it in English because, or in Russian. Actually, see, omega dt is understandable. That's the equation. Actually, it's explanation how to understand about Godot graph. Because you may see a curve there, and we have omega 1 and omega 2. And what again?
What is Godot?
Godot graph is a... Okay.
Keep saying Godot.
Godot graph, yes, it's the same name, yes, in English. Is a diagram that gives a vector or visual representation of the movement of the body or fluid. So just a curve how your body moves.
Okay.
Again, it's curve of your vector in our case.
So
But
the
it's
circle,
we have a fancy name for Godot graph.
so the circle is the graph of omega.
Yes.
Okay.
This is just some sort of magic.
It's such
There's
sort of
just-
physics.
This is just magic.
Okay, don't worry, you won't have such task on the midterm.
Oh yeah.
I explained that. Actually, it's not very popular. We are not usually work with
Sliding code.
not with with spherical motion in such cases. Just to understand, we are working with free bodies in robotics, and of course we will meet some problem because you also not used to work with angular velocities and accelerations as vectors. But for now, most of the tasks actually you can think in terms of planar. Or you can use Mod 1. Actually, you didn't have the course in Introduction to Robotics. who have known about Jacobians?
But it's calculus,
Not that jack.
Actually, in robotics, it's your main friend.
Okay.
And we can say that we are solving all our tasks using Jacobian because Jacobian helps you to go from Cartesian space to joint space. But for you, it's just some magic words.
Okay.
Actually, I solved this task on the computer using Jacobians, as we are doing in robotics way. And I have slides and so on for this. But we didn't have such courses. For you, Jacobians will be just, how to say, words, nothing else. And actually, it's better to understand how to do. You may try to do it in the next semester if you just will remember about this.
That's the same thing you studied in calculus. You just
Yeah, we have Matrica Jacobi in Russian
Yeah.
and Jacobian.
Yeah,
In
yeah.
English, they have just Jacobian because actually it means the same.
Yeah, okay.
Matrica Jacobi and this. Yes, it's the same. But what the physical meaning of this? Yeah, inside of it is just how to say matrix which help us to find the derivative, partial derivatives of our system. But in robotics, we have Cartesian space. When we have Cartesian space and we want to go to joint space, what is it? It's common kinematics. We did it.
yeah.
So because you have angles, actually we're doing the same. I mean, we have angles, theta of our stuff, and we find coordinates. It's that I ask you to do it a home task and all this stuff. And we have inverse kinematics. But if we want to work with velocities, we cannot go to Cartesian because it will be nonlinear. Our in coordinates it's linear. Actually no, because sine cosine we have. But we have let's say, let me say, derivatives. In this case it's very nonlinear. In this case we put Jacobian matrix, and in this case we can find in Cartesian. Actually we are doing the same using blah blah. When we're working with this, we also can say that we are doing something like this. So you can rewrite it in using Jacobian form, but for theoretical mechanics, when we are working with 1D, it doesn't matter, or it doesn't have any sense. To sum up, just know that it can be solved in a different way and probably know it. Okay. By the way, I'd like to put some interesting stuff. Who have heard about Celtic stone? So actually I want to show you some interesting stuff. Some magic again.
Это как та капля.
No, it's not there. So look at this guy. So here rotating in one position, and it rotates. Now let's rotate in another direction.
What is? I'm sorry. What?
Yes, it's called Celtic stone, and there are some papers how to model this guy. Okay, another guy called the Chinese spinning top.
But quick question, is it about form or is it about the matter?
Form.
Okay.
The shape of the top is.
Yeah, the shape of this, and because of inertia and blah blah blah. In moments, it tried to actually energy, let's say, conservation. Yes, because of this. It will be Russian, but actually he just I will translate. Actually, the game is just Chinese.
Mechanics.
Китайский волчок, по-нашему неваляшка. Центр тяжести вблизи вершины
Center of mass is
этой
near
белой
the white one.
полусферы. Поэтому вот так он стоит устойчиво.
So it can be stable
А вот
stable
так
position in this case.
стоять,
and
конечно,
unstable
не
position.
будет. А теперь давайте посмотрим, как он будет себя вести, если его раскрутить.
So now we are spinning this guy.
I'm sorry. What?
Поставил этот китайский волчок на попа. Центр тяжести его поднял.
I'm sorry. What?
So I told you that we have some magic stuff in theoretical mechanics.
Yes.
Всегда найдется китаец, который сделает лучше.
China breaks everything. Breaks physics.
Попробуй не валяться
Okay.
Celtic stone is very new.
Actually, there are so there are some other kind of spinning tops. Looks really strange, but I give you only told them. Now you can just show with other guys who buy it, and after they want a magic. Magic probably I will buy it to be funny to show it in the other classes.
I'd like to know how it works.
What again?
I'd like to know how it works and not just see it.
It's
Почему это
actually yes, you can Google my papers. I have found several papers. I didn't read it yet, but it's really interesting.
Олег,
Yes.
а почему-то внизу была Агла 2 написано.
Okay. Theoretical mechanics, I go up. Okay. So now we are going to the midterm. Okay, guys, don't worry. So, again, we will go through 4 tasks for 10 minutes, and our goal to prepare a strategy how to solve this guy. So, okay, I will ask one of you, and you need to think and explain the strategy. This is you. Try to think how to solve the first task.
Значит, такие же будут?
Yes. Actually, it's almost the same task as from the midterm.
So,
What you're doing first, what we need to think about. What you're doing, so, again, as you're trying to solve this task.
what I can see is that velocity of block 1 will be the same as a point in small radius of 2.
What, again, how we are learning how to think.
What do we
You need to
find?
think in terms of what?
What we have, what we need to
What
find.
we have velocities, okay.
We have velocity 1 and acceleration 1.
Okay. What we also know?
That this block connected with,
Connected.
Okay, we have some constraints, agree. What
Yeah.
else?
and we need to find acceleration 3.
Okay, we know to find acceleration. What does it mean for us?
That we need step by step find acceleration.
It means that we have to go for, we need to take derivatives. Because if we don't need to find acceleration in this case, usually we don't just need to, we can work with velocities. In this case, we need to go to accelerations.
So there is a formula
What else
that
we know?
Without derivative for acceleration.
What else do we need to know?
Angular.
Radio.
Why do I need to find the angular velocity for this guy?
No.
Why?
Because no,
There's no angular.
Why it doesn't have? I don't see any input information about it.
It's a
It has
constraint that it doesn't rotate.
translatory motion.
Okay.
Here we go.
Lisa,
That's the word.
beautiful girl, he answered correctly.
Thank.
So, translation.
Yes, мы видим
Second rotation.
Rotational. And the last one?
Planar.
Planar. In this case, yes, we can start to solve this task because we know all input, outputs, and we know that for some purpose we need to know what we need to know.
Точки, да.
Because, for
Третье,
instance, what do we know about
поверхности.
this guy?
Поэтому, когда его тянут за нитку, он катится.
It rolls.
Yes, what do you know about this guy? When you see this guy, what do you think?
It be rolling.
When you have a wheel, what we need to do?
Just to find direction.
Where will be the axis of rotation?
On the ground.
Point of connection with ground.
Yes, so you, okay, if you know the planar and you see this wheel, you already know some prerequisites how to work with it. Okay, you said that we need to go from step by step to this one. Okay, actually it's already some kind of solution. How can we, so how we can go to linear to angular for this and blah blah blah. What do we need to know? What equations do we need there?
First we need to find velocity or acceleration in small radius 2, then angular speed of circle 2, then speed of big radius 3, or big radius 2, and after it
Is it the same, no? Wait, two is too big, too small.
yeah, it is the same.
Okay.
Velocity too big. It will be the same as velocity 3.
The top velocity.
Top velocity.
Ah.
Yes. And after this, you just using IC find other stuff. So actually, we may say that we solved this task in 2-3 minutes, because after this it's just implementation. Because we know the algorithm, we understand what we have, what we need to have, what we need to know. Actually, for me, it means that you already solved the task. It will be, if you write this kind of stuff and you explain what your algorithm actually, it's about 70-80% of the solution. Yes.
Здесь, если мы напишем это, то у нас будет...
What again?
Is it possible to solve it without knowing the radius?
No.
No.
You need
So
to
we
know
just-
you need to know how it converts from the small radius.
Yeah, that's like. So this is the whole task, or we are missing the radius?
For now, most of the task contains that you have all dimensions. Just don't worry about this. Originally it was in Russian and just translated and dropped some useless part. Actually, you said about, yes, if you wrote like this, but not like this, but to explain it a bit more, yes, it's about 80%. Because actually you can convert it to equations. You need to show that. I understood that it's convertible using, for instance, v equal to omega r. Actually, it's already algorithm. If you didn't put any numbers, some tasks you even don't need it. In some tasks you need it, but in this case I just dropped about, I told you, 10-20% actually.
Yeah, but here we found the velocity of the top, but we need to find the velocity of the
Center
center of
of
mass.
mass.
Center of mass, yes, it will be the center in this case because it's a disk.
Mhm.
And you know IC,
Is it at the bottom?
yes, it's at the bottom and you just need to,
Okay.
because in this case our angular velocity, angular acceleration will be v3 top divided by 2r.
Oh, right.
Yes, and it will be VC, I mean, for its center, it will divide radius.
Yep.
Yeah.
Right.
Okay, next task.
Accelerations.
Accelerations, I hope you find.
Accelerations are not exactly the same.
Not exactly the same because you have tangential and normal.
Yes.
Okay, do you want to say the strategy?
I'm just thinking about how it would define the acceleration of the center of mass of row 3. We know the tangential, we know the normal it at the top point. Why, like the same
Yes.
procedure as the velocity. But how would you translate that to the?
Actually,
The
you,
normal
do not,
same.
you need to check, do you have angular acceleration? If you don't have this,
You have angular acceleration.
so if you have this, you can find it somehow. So if you times, yes, actually you can take derivative of omega. Yes, in this case you can write this, oh, I forgot the equation. R, whatever.
Yes.
R. You have omega square R. Yes, of course, and you will have normal.
Should we find angular acceleration, just acceleration?
As well as angular.
Actually, acceleration has a direction. Don't forget about it.
acceleration as well as
Oh, yeah. Angular acceleration will be like on the same action line as the angular velocity because it's a planar
Wait,
mode.
besides angular velocity, angular acceleration, если мы найти
As well as angular velocity and acceleration.
Они оба angular.
Они оба angular?
Да.
Yes. I don't know how to write it. Each time I dislike to write it. Angular velocity, angular acceleration, velocity acceleration. I prefer to write
Так
just.
понятнее хотя бы.
Да.
Ну и так уже есть.
It's already
acceleration,
said that you
по-моему.
will determine acceleration.
Вряд ли одна и та же.
Не было
Давайте agreement добавим.
Давай, окей.
Ладно.
So what's the agreement?
Пожалуйста.
Пожалуйста. Okay, I will write our agreement, пожалуйста.
Описывай задание
Please
максимально
describe. Да. Please describe the tasks as deeply as possible.
Dark deep fantasy. Окей. Please try to explain what need to do.
Well, I haven't read the task yet. Wait.
Все, сколько будет заданий?
4 probably. Or something like that.
open book.
Actually, we have, yes, open book. Probably. If not mistaken, yes, open book.
So 2 on kinematics, 2 on statics.
No, probably it will be 4 on kinematics and 2 on statics.
How much time do we have?
2 or 3 hours.
So we have 6 tasks.
3 часа на 4 таска.
Guys, we solved this task in 10 minutes, come on!
Yeah.
It's because we didn't need to write the whole solution.
That's also true.
yes.
Wait, what moves here?
Don't worry.
Acceleration.
I will say, I don't remember because I already prepared this. I had a meeting for 3 years and I already have all of the stuff. I cannot say what exactly the amount of tasks. Right now I don't remember. So, think.
So we have a wheel and the rod on top of it.
Looking at this task, what the main problem
I'm
can
trying
be?
to understand how it moves. Wait. Ah, the rod moves.
Angular
So-
velocities for the links which belongs to
The
this
rod
point.
one
What does that
has
mean?
translatory motion and it makes the whole mechanism move. But by mechanism I mean the other wheel. And we got determinant and
Непонятно, кстати, C зафиксировали.
if we have a rod 1 as translatory motion and wheel 2 as planar motion, then
Did we see this kind of task before?
Yes.
well,
What the
Similar,
problem
not
was?
the same.
Actually the same, but with different picture.
I don't have that good
No,
memory.
the bottom, in this case, the bottom is stationary,
Oh,
but
wait.
the other one was, the bottom was moving.
Yeah.
So it's,
It's like moving with velocity equal to 0.
Okay, so
Pure genius.
the second, what we need to find in the second is just the angular velocity of the web, like the second link,
Whack.
and that's it. As I'm reading this right, it's just angular velocities for the links which belongs to these points,
Like
which is second
So,
link.
for instance, in first link you don't have angular velocity.
Yes.
You need to just write it's translational motion, no velocities, goodbye.
wait, what is a link? What do you
One
mean
and
by
two.
link?
angular.
1 and 2 is a link, and ground is a link, I guess.
So point A links 1 and 2 and the ground, right?
Point A belongs to 1 and second.
Yeah.
Point B and C belongs to second link.
Okay.
Well, D belongs to ground.
We don't have D.
If you place D, then you'll have D.
I see. You
I
can
see.
go
I
like-
see.
I
Yes.
see.
I see. Well, we know what's given, we know what we need to find. Then we write which links go as like the motion of which links of every link, and then
Of course, you know R is given. Yes.
R are given.
Actually, what is the difference between this task and the previous task?
We know the radius.
Nice answer. I like it. What else?
We can find omega. V cross R, R cross V. Divided by R squared. By 2R squared.
In the previous task there was a link in between. In this task there is no link in between. It's actually easier.
Yes, exactly. It's the same task as the first, but yes, this looks.
Звезда смерти.
Yes, you
What
need to
does it have
destroy
a
that.
line?
Okay, what the topic is it? Can you understand it looking on the picture and this guy?
Теперь она еще вращается вокруг точки О.
Что?
Это relative transport.
Yes, it's complex motion. You can understand because you see the point which have the low, some low, and it moves somehow. Do we have Coriolis acceleration there?
Yes. Like it should be. It can be equal to 0, but it is.
It exists.
When you are a foxy guy, that yes.
I think we don't know the actual laws that they move. We can at least I guess write derivatives.
Again, first of all, what we are trying to do firstly?
Understand what we know.
Yes, what we know. We know law.
We know the
Martial
nature
law.
of the body.
While you were studying theoretical mechanics, I was studying the martial law.
Есть что-то вопрос? Таски
And then we
неправильные.
know the position of point M.
Point M. Also, we also know the law.
How it moves.
Yes.
No, the T is equal to T1.
Okay, we know T1.
Yeah. We know the point of time.
Yes. For us, it actually doesn't matter because we will put it in the end.
We know the first link, I guess, the
Yes.
only link.
Link, okay.
It moves in a planar motion.
Planar motion.
Rotational motion.
I'm bad. Rotation.
Say if you didn't get.
No, I'm thinking about point M. What does it mean by positive value of natural product? So this is the positive.
Just says that M is like OM is positive, I guess.
Yes, OM is positive. The length is positive.
Then M
It's just about direction. That's it.
Okay.
So it's rotational. Do you agree?
Yes.
Okay. The second link.
Linear. Relatively linear.
Yeah.
Relative to the circle, it's linear.
So actually, when you look at this task, you understand that we need to use acceleration. Actually, do I need to find acceleration? Yes, velocity and absolute acceleration. In acceleration, we know that it should be Coriolis. And we need to understand, does it have a no? Actually, it's the first case. It has y.
Because we have both rotational and linear.
Because we have rotational. And yes, actually, yes, because our omega exists and our, velocity exists. Because it's linear, it means that we have yes. That's it. After this, we just solve the task as the previous one.
No.
We took the derivative for theta, we took the derivative for s. 2 times we find accelerations, velocities,
Don't
and
forget the Coriolis force.
yeah,
The
it's not
acceleration.
force.
Acceleration.
Acceleration.
Yeah. And that's it.
Yes, you find velocities because we have this point. Actually, again, it looks like the car. It's not in the center of rotation, but in the bottom of rotation.
Они должны просто вспомнить их.
What the tricky moment will be there?
So which direction will the ruler supposed to
Если
be?
все объекты
Because
рождаются
it
с
will not be on
You don't know.
просто по ходу жизни.
You will have the problem, guys, there with MO1.
You actually don't know the directions of both angular velocity and linear relative velocity, so you cannot find the direction of Coriolis force. But you can find the action line, I guess.
But this problem, you can guess. Do you remember that with solve the task when you guess some direction after this? When you solve the equations, you receive either positive or negative. What about this? How can we find this?
The line.
What?
MO squared plus R squared.
Yes, actually you already know MO because of S. And you know the radius. And you can find easily MO1. Because it moves and when we're solving this task, we need to consider this.
That's for the
Transport
transports
for transport velocity of point M.
and accelerations.
Yes, for acceleration. The last task. It's home task, okay. Free time.
Uh-oh.
Sure.
Is that also for midterm?
No, it's big home task. The same task. Actually, it's from the same book, from the same solution. For your practice. Again, simulate mechanism, find absolute transport and relative velocities and accelerations to point M, find T, when the M reaches O. So because
Oh, complex motion.
yes. Actually, we didn't have practice, you will have it in the home test. I am not the Han. Do you know this? He is a famous speech about that. If you don't know some, if you didn't learn something during the class, you will learn it during the midterm exams. He did it a lot of time.
Oh, and the coordinate is given in the dimensional form.
Actually, I give you. Does it look like the? It's a more complicated version of this.
Yes, because it's not linear.
M moves in
Relative.
Yes. How's your research task? I saw that some of you tried to solve it.
Yeah. I found a solution to this one, and I tried to find the other ones.
Is it interesting?
Very. Second evening, I was like, not.
Because of its interesting.
Yeah.
Because I was the kid that was all this guy. Привет. Yes, so